After this basic introduction to random variables, let's take a look at a few examples. The first one involves what is known as change of variables. Let's take a minute to read it carefully. So v0, the initial velocity, is a random variable, and there is the direct explicit function relationship between d and v0. So d is also a random variable. We are not interested in finding the distribution of d if we know the distribution of v0 at this stage. All we want to know what the mean of d is if we know the mean and variance of the initial velocity. So let's start interpreting some of this given information. So the mean of v0 is 10 meters per second. The COV, the coefficient of variation, this is a very useful engineering metric that we have for describing random variables. It is the standard deviation divided by the mean. So the standard deviation of v0 would be 0.2 times 10 meter per second, so 2 meter per second. What we need now is the mean of d. We already have seen that expectation is a linear operator, and since 1 by g is a constant, the mean of d, or the expectation of d, is that constant times the mean of v0 squared. Now, how do we get the mean of v0 squared? We have been given the mean and the standard deviation of v0. So we'll use the known relationship between the variance, which is the square of the standard deviation, and the expected value of the squared random variable and the mean. So variance is expectation of the squared random variable minus the square of the mean. So expectation of v0 squared is the sum of the variance and the square of the mean. If we put in the numerical values, it comes to 104 meter per second whole squared. So plugging in the value of g, the mean maximum range d is 10.4 meter.